Hey everybody, we're going to move on to part 3. Here we're going to be talking about two-handed limits. So what does that mean? So back when we did this the first time, let's go back. Back when we did this the first time, oh hey, we just plug it in, we're good. Here, the limit just works. We haven't been, this is what we were talking about here. This is a two-handed limit. From the left and from the right, everything's fine. Here, when we were doing these, the left and right-handed limit were different, right? Most of the time. Here, they were the same. And so what we're going to do is we're going to look at some of these and determine, first of all, does a limit exist? And if it does, what is it? So we go through and we have our thing right here. And remember we were talking about looking for looking for the limit from far away. Here's our special safety fence that we're trying to find the limit here. And we're going to slowly move in, right? We're going to slowly make our way in closer and closer and closer. And the thing of it is, if the limit exists, if in fact our limit does exist, we should be able to get closer and closer and closer. We should be able to zoom in on that point, get as close as we want, and still have the two sides connect. So let's go through and let's look at what we're talking about. Take a look here. There are two ways to think about this, visually and numerically. Let's start visually. We're looking as the limit approaches 0 from all directions. I'm going to draw our fence. And eventually, I can't draw it to the point where I'm circling both anymore, right? This limit can exist because it doesn't go to the same place from both directions. So visually speaking, like if we're doing a multiple choice problem or something like that, visually speaking, you can just look at this, see, hey, look, the two places where we approach 0 don't match up, so this does not exist. But obviously, if you need to show your work, we got to do a little bit more. And the easiest way to do this is show the left-handed limit and the right-handed limit. Are equal. If they're equal, then the limit exists and it's at the place where they are. If it doesn't, if they're not equal, then it can't exist, right? So we're going to go through and show, does it or does it not? If it does, then cool, we find out what that is, and then that's our answer. If it does not, if they're not the same, then our answer is it does not exist. So let's look at what happens. So let's look at the limit of this function as r goes to 0 from the left. From the left, we're going from the left, we're coming this way, and we see that the limit approaches -4. Now let's look at the right-hand limit. The limit as r goes to 0 from the right of our function. What is that? Well, let's look. What is this approach? Well, this approach is +4. Are these the same? Well, this one's 4, this one's -4. Those are different numbers, right? The limit does not exist. That's how we do it. Visually, it's clear that it doesn't exist because they don't touch, right? But if you don't get this picture, you still have to figure out. And so what you can do is you can just approach, see, hey, what is this limit going to be? Use that little chart we came up with. Well, what is it when r is coming from the right? It's going to approach 4. What's it when r is coming from the that's going to approach 4 too. So negative 4 too. And so you can show, hey, they come out to numbers that are different, therefore does not exist. Hooray! Let's do many, many more. Give this one a try on your own. See if you can figure out what the limit is if it exists. I'm just going to put these out here. Because it's the same thing. We're just going to go from the left, see what that comes out to be, go from the right, see what that comes out to be, and get our answer. So let's look. What's that approaching from the left? Bloop. Negative 1, right? What's it approaching from the right? Bloop. Negative 4. Are they the same or not? Definitely not the same. Negative 4 and negative 1 are not the same number, and so we know that they are not the same. And so the limit does not exist. Same idea. Give this one a try too. Are they the same or are they not the same? Let's find out. From the left, follow the branch down. What's it come to? What's it about? 2, right? Follow the right-hand branch coming from the positive. What's that one approaching? 1, right? And so, not the same? Does not exist. So if you notice that there's a break in the graph where you're looking at the limit, if the two sides don't touch, if they're not holding hands, then you know that they can't be making a limit together, that the two don't match, they don't have a limit at that point. Anywhere else probably is fine, but anywhere you've got a jump, that's what this is called here, a jump. Anywhere where it goes, and then boop, it goes to a new place. Teleports, it goes through a portal, right? This is thinking with portals. Portal down to here. Anywhere where there's a portal like that, where it jumps from one place and then appears in a new place without connecting, the word we would use is discontinuous. Any place where you see a discontinuity like this, where they don't link together properly, well then, doesn't exist. Here, the same idea, right? We're looking to figure it out at 2. This spot, right? Coming from the left, this greatest integer function, I'm not going to write out, this greatest integer function, lesser integer function, this floor function, as it were, coming from the left, gives us negative 4. But coming from the right, from that perspective, we're at -5. Not the same. Once again, does not exist. Let's look at some where they do exist. So again, here you could just plug stuff in, or we can look. So it's x is approaching 2. This spot right here. That sharp corner is. Well, do the limits converge to the same place? Is the limit as x goes to 2 from the left of function h of x, is that the same as the limit as x goes to 2 from the right of function h of x? Well, let's look. What's this approaching? -3. This is approaching also -3. This is -3. This is -3. Are they the same? Sure are. Since they're the same, then the limit does exist. And we can say that the limit as x approaches 2, the two-handed limit, see there's no plus or minus anymore, the actual limit of h of x does exist, and it is -3. That's what it comes out to. Let's do one more. Try this on your own. See if you can figure it out. I'm sure you'll look at it and you'll say, oh, this is really easy. But if this comes as like a free response type question on the AP exam, remember you have to show why. You can't just look at that and go, oh, the answer is, if it's a multiple choice, go ahead and do that. But if it's a free response, at least show your steps. So like this. Again, the left-handed limit as t approaches -3 from the left of our h of t function. Well, what does that come out to be? We're going to -3 from the left. That is -3. Well, what's the other limit? What's the right-handed limit? Let's follow the line this way. What's it going towards? Well, this is our point coming this way, and the y value here is -3. So if we look, and I'm in the way of this, aren't I? Let's move me out of the way. Let's look. Are they the same? That's -3. That's -3. Hey, they're the same. So the limit as t goes to 3 from both sides, the two-handed limit of our function had better be -3. And that's all there is. It's not very difficult. Don't let this freak you out. This is literally doable in your calculator, or they're small numbers. You can probably do these on paper. You don't have to pull out a calculator or anything like that. But you know what the answer is going to be. We're going to show why, but you know what the answer is going to be already. You can follow, right? You can follow this like that. You can follow this like that, and you can see what they're both converging towards the same thing, right? And so all we have to say is, well, w is approaching -2 from the left. When we do that, we get 5. W approaching -2 from the right of our function h What do we get? We also get 5. Well, okay, they're the same. So the full honest to goodness limit without the handed stuff, it's just we're going to -2 from all directions. So the answer has to be 5. And that's all there is. When we're doing this, I'm going to move me over here. When we're doing this, these are the most complicated things. Everything else is just applying algebra you already know. And so we'll go through some of those in another video. But these first 3, just plugging it in, or just looking at from one side or looking from the other side, or having to check both sides to see if they match. These are your basic limit ideas. These are what we're trying to do. We're trying to approach something, and whether or not we see something when we get there is dependent on whether or not our limits jive together. In the first situation we had in the first video, part 1, it jived. It always jived because there was no problems. In the second one, we're just following one path and seeing where it leads us. You just take your finger and move it to the end of the road till you get where you're supposed to go. What is that supposed to be? And then part 3, we put all that together. Does a limit exist in these weird situations? Well, let's follow both. Do all paths lead to the same place? If not, then no. If so, then yes. Have a good one.